Hello dear friends, today we are going to see what is corrosion, how can you able to control the corrosion problem. This video lecture we are going to cover what are the different corrosion forms by knowing the classification and theories, what are the reasons for corrosion problem, what are the different types, what are the factors, how can you minimize the corrosion. Okay. Right, before that you must know the basics of electrode potential. For that you must recall what is the metal, how the metal ions going to solubilize when you are putting in an electrolyte. Few metals have the tendency go for oxidation, that is a dissolution. Few metals going for protection, that is a gain of electrons. Please recall that is called redox reaction. One is oxidation, another is a reduction. So how it is going to influence in the corrosion problem? The metal which is undergoing oxidation, that is always going for the loss. We can please remember that is always in the form of an anode. The metals which is going to gain the electrons, the tendency is going to protect the surface, that is always in the form of a cathode. Please remember, when you are putting a metal in its electrolyte, it is going to form a double layer. This is so-called Helmholtz electrical double layer. So when you see the electrode potential, when you connect two half cells, which is one is becoming an anode, another is becoming a cathode. In the case, what we mention is zinc and copper forming a Daniell cell. If you connect it, the zinc become an anode, copper become a cathode. So it is going to form an electrochemical cell. So when it forms an electrochemical cell, you can find out what is the electrode potential and how the concentration varies the electrode potential by using your Nernst equation. Please remember, the Nernst equation is derived from the thermodynamic principle. Right. Now, after finding the electrochemical potential, people are going to form an electrochemical series by keeping a hydrogen electrode as a standard. You know well, the electrode potential of hydrogen electrode at a standard condition is 0. But for a corrosion problem, you have to make it for sodium chloride as an electrolyte. So, the electrochemical series become a galvanic series. It will give information about the corrosion behavior. The next slides will give you an idea about what is the electrochemical potential for the metal which is kept in a orderly manner from starting from lithium to fluorine. Based on that, the galvanic potential against a reference electrode, here the reference electrode is standard calomel electrode, you can find out the value of electrode potential. Based on that, you will able to predict what is the corrosion potential of a metal when it undergoing the environmental problem. Right. After knowing the theory, you can say what is corrosion. The corrosion is nothing but deterioration of the metal when it comes to the chemical or electrochemical reaction. What is electrochemical reaction? What is chemical reaction? Please recollect. We will see what are different forms of corrosion by citing some few examples. So this is a day-to-day example. You can see how the metal is deteriorated. Few more examples. This is for the construction side. This is for the metal which is kept in the concrete, like that. Okay, right. What is the forms of corrosion? Why you have to study? Why? The reason is the economics and social loss, because what you paid for a metal is no longer metal when it going for the corrosion. So it is having a direct impact like maintenance cost, material loss, preventive maintenance, labor charge, etc., etc. Sometimes in the industry even you go for a shutdown. So it's a heavy loss going to occur. That other than that, the human safety is very, very important. That is why you have to study the corrosion, forms of corrosion and control of corrosion. let us see few examples for the dimensions of the corrosion problems. So this is a chemical plant where it is releasing the heavy toxic gas, it end up with the corrosion. Pipelines carrying underground, civil bridges, then it is forming chimneys in the big industries, corroded pipes. Because of this, you are getting the reduced efficiency. Right. What are the classification? The reason behind the classification is how the metal is end up with the environmental factors. When it going to face a dry gases, it is going to form a chemical reaction that's called dry corrosion. But at the same time, when it interact with the aqueous media, or we can say as an electrolyte, it end up with the wet corrosion problem. It is going to form an electrochemical cell. Otherwise, people also call dry corrosion is a chemical corrosion, wet corrosion is a electrochemical corrosion. Right. What is the chemistry? The theory of chemistry here is oxidation, corrosion by other gas, electrochemical attack. The attack may be in the presence of acid. The mechanism is hydrogen evolution, or in the case of neutral condition, that oxygen is going to absorb. People also call differential aeration corrosion or concentration cell corrosion, where the metal is going to face the same electrolyte but different concentration. Let us see few examples for each corrosion. Here the anodic reactions, metal is going for the loss, oxidation, cathode, always reduction, but depending on the presence of electrolyte, the cathodic reaction may be evolution of hydrogen, absorption of O2 and forming OH minus ions. Right. There are other factors which influence the corrosion. One is surface heterogeneity. People call even a 0.1% impurity in a pure metal causing a tiny galvanic cell that will become a bimetallic corrosion. Then some of the environmental variations like temperature, humidity, presence of soluble chemicals, gases, then mainly sodium chloride environment, that all going to cause corrosion problem. Severity is more. This is a typical example of how dissimilar soil corrosion cell is going to form. Say for example, in a soil, you are having different soil nature. Say for example, wet soil, clay soil, like that. So when a pipeline undergoing a different soil environment, it creates a problem. This is called soil corrosion. Next one, we will see pitting corrosion. What is pit? A small hole going to form on a surface that is going to become an anode. The very large area going to become a cathode. So the anode, a small area, it's going to serve more electrons to the large cathode. So what happened? The small pit become very wide line crack. So pitting corrosion is a severe problem. Next, so differential aeration corrosion. Same soil but different environment. Say for example, wet soil, poorly aerated soil. This going to create oxygen concentration difference. So the low oxygen accessibility part become an anode, high oxygen accessibility part forming a cathode. So when it going to form an anode and cathode part, naturally anode part become a loss, where we can say it's a corrosion problem. Likewise, we are having deposition of scale or deposition of mud or sand or bacteria. So many things causes a differential aeration problem. Say further example, say typical example. Say we are having a small anode, large cathode, where you are having the rivets. So differential aeration corrosion. Likewise, one more example. So when you are having a coupling with the screw and nut, you are having a lower oxygen accessibility, that leads a part of a anode. Okay, you are having a typical different examples, and you can even see the day-to-day problem. Like for example, your pipelines under the marine condition, pitting, small pits become a big crack, then zincification, stress corrosion. So many things. You see, this is again the erosion problem. So you have already seen what is corrosion, forms of corrosion, typical examples. Now our point is how to control. Point number 1, depending on the metal you can select or you change the environment. That's called modification of the environment. For otherwise you can go for some methods to control the corrosion. The methods of control is, one is you can choose the inhibitors. That is, it is giving a chemical which is going to act as anodic inhibitor or cathodic inhibitor or neutral or sometimes even in the form of a vapor. So this inhibitor will help you to minimize the corrosion rate. Then coatings, you know very well. Coatings, whether it is organic coat or inorganic metallic coats, it will going to safeguard your metal. These are typical examples of how coating is done on a pipelines, whether it is anodic coating or cathodic coating, the metal like that. So it is going to form your base metal, whether it is anode or a cathode, right? For typical example is alloys. So another example I am going to give is how your ship hull is going to protect by sacrificial method. The ship hull is made of iron. So you connect a more reactive metal, it's a magnesium or aluminium, so that that metal is going to form an anodic type which is going to sacrificially oxidize, so that ship is going to protect. Right. So far we have seen what is the problem of corrosion, what are the types, reaction behind, and few examples and protective methods. Thank you.